This is the tutorial for the Unit 4 End of Chapter project. It's called Simulating Binomial Probabilities. And what you're going to do is decide on an activity that has a definite success rate. You have to be able to state the result as something that is right or wrong, hit or miss, success or failure. And do be sure to send me your idea in an email so that it can be approved before you begin working on the project. Here are some ideas that you might want to use for your project. Idea A is to select a playing card from a deck of cards. So choose a particular card before you pick a card from the deck. For example, you could choose to draw a king or not a king, draw a 5 or not a 5. So if this is what you're choosing, maybe you don't want to use the entire deck of cards. Just choose one suit or some cards at random, maybe 10 cards out of the deck. And you would be testing for drawing the king or not a king from those cards you begin with. Part B, you could draw a green cube from a bucket of similar cubes or different colors. So maybe you have some blocks at your house and you have different colors of them. You would be testing whether you choose a particular color or not a particular color. With the chip flip activity, you might have a plastic chip that has two different colors, and when you flip it, it could land on the red or the yellow or whatever the colors are that you have. So you would have to choose which color you're calling success before you begin flipping that chip 50 times. For part D, the dice roll, you could use one die. Since there's 1 through 6 on a standard die, choose one number before you begin rolling the die. For example, you could choose the number 3. So you roll the die, it either lands on 3 or it does not land on 3. Or maybe you have some dominoes for Project E. With a domino, there are dots on right and left side of the domino, and you could choose combinations such as 2 dots, 6 dots. So if that's what you're choosing, you either are selecting the domino with that pattern or not selecting the domino with that pattern. So whichever of these activities you choose, or you may come up with your own idea as long as it can be determined what success or failure is for the activity. You're going to do the activity 50 times and record your number of successes. You're going to calculate your success rate, and you're also going to determine the probability that you will have 4 successes out of 14 trials. You're going to collect all of your results and make a PowerPoint presentation. So you're going to explain your activity, and pretty much that's just step by step, what did you do? You're going to report the number of successes and the number of trials. You're going to show your success rate calculation. You're going to report your probability of success and failure. You're going to show how you calculated the probability. You're going to write an experiment as a problem that could be worked by other people. And of course, then you're going to show your results. I will be checking for grammar and spelling, so make sure that you're using a spell checker and you double check your work. You should have capitals and periods and correct spelling. You're going to use a title or slide page and make the presentation look professional. You're going to submit your PowerPoint saved as a PDF. Remember, if you don't save it as a PDF, I'm not going to be able to grade that in Blackboard and write comments on it. So I'm only accepting PDF format. Make sure that you submit that into Blackboard. I do have a PowerPoint presentation sample that I'm going to show you now. So here is my title page, and these are various highlighters. For my project, I wanted to determine the probability of drawing a blue highlighter from a handful of similar highlighters of different colors. This is the procedure that I used for my experiment. I used one highlighter of each of the following colors: blue, orange, pink, purple, and yellow. I held the handful of highlighters under my desk so I couldn't see them during the selection process. I selected a highlighter one at a time and returned it to my handful of highlighters and repeated this process 50 times. I recorded the results after each selection and transferred the results into a table. Now, you will only need to include in your table what you determined as success. But I wanted to see what the results were for every color, so I expanded my table, and you're welcome to do that also. You could have one column for success and one column for failure if you choose. So blue is what I was choosing for success. So all of these other colors would be failure. So I'm mostly concerned with this column of numbers dealing with the blue highlighter. As you can see in the table, I've included the number of successes, the outcome for the 50 trials, the success rate, the probability of success for blue, the probability of the complement, that would be the failure, and binomial probability distribution. So this binomial probability distribution was found by using the binomial probability formula. In this slide, you can see the binomial probability distribution. In this calculation, it is 4 successes out of 14 trials. And you can see the result for blue is not 0%. It's 0.2304, which is about 23%. So that's why I chose 4 successes out of 14. I also included all of the other color highlighters. In this slide, you can see when I tried 12 successes out of 14 trials, I had 0.000010955. So that percentage is basically 0 because when I multiply by 100, the decimal moves 2 places to the right and I would have 0%. And you can see that all of these probabilities would turn to 0%. That is not useful for this experiment. That's why I chose 4 successes out of 14 trials, because none of these then end up with 0. The explanation of results. Although I initially set out to determine the probability of drawing a blue highlighter 4 out of 14 times from a handful of different colored highlighters, I was curious about the probability of drawing each of the other colors of highlighters as well. Now, you don't need to do that, but you may. I used the binomial probability distribution formula to determine the probability for each color of highlighter. And since the probability was 0 for 12 successes out of 14 trials, I needed to calculate the probability of 4 successes out of 14 trials. So the question I'm asking is, Mrs. Varela has a 28% success rate with drawing a blue highlighter from a handful of similar highlighters of different colors. What is the probability that she will choose 4 blue highlighters in 14 attempts? And the answer is the probability of drawing a blue highlighter from a handful of similar highlighters of different colors 4 out of 14 times is 0.2304, or 23.04%. So the last thing I would like to show you in the tutorial is how to get PowerPoint to include this binomial probability formula. There is one built in, but it's not quite in the format that we're using for this class. So I used Word. So I'll open up a Word document. Once your Word document is open, what you're going to do is insert an equation. So I might need to expand this until equation appears. And you can see the first thing we have in our binomial probability distribution calculation is a parenthesis set with our 14 choose 4. Or you might be using 14 choose 12, but I think most of us are going to end up with 14 choose 4. Notice that there's no fraction bar. It sort of looks like a fraction, but it's a special notation used for this binomial probability. So we need it floating. This is how you can write those numbers in parentheses. So in Word, I'm choosing to insert an equation, and I'm going to look for the icon that shows the parenthesis. I'm going to go inside of that parenthesis and type 14, enter 4. And now you can see that it is floating just like in our binomial probability distribution. So clicking outside of that parenthesis, I am now going to enter my success rate raised to the power of x. In this case, x is worth 4 successes. So to write that, I need to choose script, and that gets me a box raised to a box. So in that small box to the power of 4 is what our success is, but the rate inside, I need to choose another parenthesis, and I can put my 0.28 or whatever rate of success you have. Clicking beyond the 4, you can use arrows to go past the 4. And I need another parenthesis or another box to the box. And I'm choosing a parenthesis. So 0.28 is the probability of success. So 1 minus 0.28 would be 0.72. To find the exponent needed here, you're taking n minus x, or 14 minus 4, and that would give me 10. Once you have all of your numbers entered, you're going to click on the box on the upper left-hand corner so that everything in your formula is selected. You could then Control-C to copy, and then Control-V to paste that into your PowerPoint. The next thing that you're going to do once you have your PowerPoint selection all complete and saved as a PDF is you're going to go in and submit your assignment. I hope you found this tutorial helpful to complete your Chapter 4 project.